Okay. Cofunction. Max, what's the cofunction of cosecant? Sine. Good. So we're actually going to graph 2 sine x plus pi over 4. Now hopefully by Friday we can look at that as a sine b x minus h. So there is no k. So I will ask you for amplitude, period, phase, vertical. Okay? All right, Jasmine, you have amplitude. So what's the amplitude? 2. Thank you, madam. Period. Haley, the normal period for cosine or for sine is what? Pardon? Very good. And is there a b that we're dividing by? No. Excellent. Max, phase shift.
Left, pi, 4.
Good. Max, vertical shift.
Max again.
Yep.
Oh,
None. Sounds good. All right. Let's graph it. Now, our amplitude is 2. Our midline is good, so we don't have to move the midline. We're going to go left, though. So leave yourself enough room to go left. Okay. Lovely Haley told us our period is 2 pi. We want to leave ourselves room to go left. All right, guys? And we're going left pi over 4. So pi over 4 is like the little halfway mark between pi over 2. So between all our ticks, we're going to put little ticks for all those pi over 4s that we have to shift left, okay? All right, so let's graph our original graph as dashed. Matt Sarver, sine starts up or down? Down. So we have x-intercept. Halfway point, we have a max. Next halfway point, we have an x-intercept. Next halfway point, we have a min. Next halfway point, we have an x-intercept. Let's go around the other way. Max, x-intercept, min, x-intercept, max, x-intercept. Sounds like I'm saying max all the time. Okay? So let's do this as dashed, because then we have to shift. I'm going to put my other little pi over 4s in here. Alright, so everything goes 1 tick to the left. So 1 tick to the left. Here we go. 1 tick to the left. 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 But Is that the graph of cosecant? No, it is not. Anywhere where we have an x-intercept, what do we have to draw, guys? Asymptotes. So asymptote. You can make them dashed if you want, it doesn't matter. Asymptote. Asymptote. So this is a way for me to check on a test. I'll look if you have your asymptotes in the right spot. Okay, and final is the u's. So at any max point we have a u opening up. At any min point we have a u opening down. Amplitude, period, phase, vertical. Joel?
Yes.
Amplitude. 1. Joel, normal period for cosine. 2 pi, and we need to divide it by? And so we get? Just pi? Yep. Joel, phase shift? So anything in parentheses with x? No. Any k value at the end? All right, this one should be easy to crank up. Joel told us period is pi. Okay. So Brianna, can I have halfway points, please? Pi over 2. Half of pi over 2. So Brianna, 1 pi over 4, 2 pi over 4. That a girl. Thank you. Okay. All right, Miss Hannah, cosine starts up or down? Up at the amplitude. So up the amplitude, the next halfway point is x-intercept. Next halfway point down the amplitude. Next halfway point x-intercept. And then up the amplitude. And then do the other side, guys. Draw it as dashed, remember, because this really isn't secant yet. Okay. Then Mason, what happens next? For secant. What do we have to draw in? The asymptotes. On the negative side, where would you like your first asymptote at? What x value? Yes. Sounds good. We like these, don't we? When we don't have any shifting to do. Yeah. Life is good. What? You can. Yeah, it doesn't matter at all. All right, and then finish up with your U's. What I've seen people do on the test is they draw the cosine 2x curve. They even draw in their asymptotes. And then guess what they forget? They forget to draw in the U's. Okay, so make sure you guys draw in the U's. A value. What is the A value, Natalie? It is 2. Okay. Period. Is the normal period for tangent and cotangent. Tangent and cotangent have the same period. It is pi. Divided by 1/3. So yeah, is 1 divided by 1/3, is that, Autumn says it's 3. Anybody concur?
Yeah.
You have your calculators. You'll have your calculators on Friday. So yes, this is like 1 divided by 1/3. And 1 divided by 1/3 is 3 pi. Okay? Now remember, cotangent is different. It's not centered around 0, 0. One of its asymptotes is actually on 0, 0. Okay? So one of the asymptotes is on 0, 0. The A value is 2. So we have up 2, we have down 2. So one of the asymptotes is on the y-axis. So there's an asymptote. The other asymptote is over the period. So where do we have to go over to, gang? 3 pi. And that's where our other asymptote is going to be. And let's do halfway. What's half of 3? 1.5 pi. And half of 1.5? 0.75 pi. What's 1.5 plus 0.75? 2.25, sure. Will you let us do decimals? Yes, I will. All right, so we have our other asymptote. Okay, at this halfway point, we have an x-intercept. Now, at the first halfway point, are we up or are we down? We're up. That's the difference between tangent and cotangent. It's the opposite. So we're up the A value. At the second halfway point, we're down the A value. Oh, we like tangents, don't we? Are they really not so bad? So guys, the main thing is you have to remember that your asymptotes for cotangent are not centered around 0, 0. One of them is always on through 0, 0. The other is over the period. Okay? All right. So doing good? Good, 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 good. All right.